This is the Amp Hour Podcast. Released December 6th, 2020. Episode 520. Inductance and stuff.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
Want to jump into something that we know absolutely nothing about?
Unlike usual.
RF.
RF. What about RF?
I just did a teardown yesterday. I'm going to edit, release it today, and it's a aircraft transponder.
Oh, interesting.
Rather interesting. Made in Australia. Thank you very much.
Recently or no?
Oh no!
Like, is it modern or is it?
It's still a current design, but it was designed in 2000. So
okay,
it was first sold in.
But still active and still being.
Still active, which is common for these bits of kit. You know, it's like you design them once, and it's got a PIC micro in it. Spoiler alert. And it's like that's why companies like Microchip and other companies, they still make the same micro because somebody designed it into a product 20 or even 30 years ago. Yeah, exactly. And that's why they still sell the PIC 16C84. You know, you can still buy it, right? I think you can still get it. Better check that. Hang on. PIC 16C84 DigiKey. I'm not talking about that new flash rubbish. Right. The old CMOS version. Let's see if they have it. No, you might have to go to F.
I have a product that I'm like kind of updating for the modern era, and like, you know, the underlying bones of the thing, there's, you know, it's got a couple PIC micros in there. Like, it works great. Like, honestly, it's like industrial equipment. Of course it works. You know, like, it's like there's aside from the fact that it needs to, you know, go on the internet now, because that's, you know, a new thing. Like it's great. The underlying stuff that, you know, there's some bugs maybe, but it's fine otherwise. So, and I think it was built 20 plus years ago. So
no, I don't think you can still get the 16C84. I think you have to transition to the F. But Microchip, I believe, has a transition document for going from the C to the F, which is not much. You just have to, you know, I think you might have to recompile the code. Not sure. But anyway, or just program it differently because it's choose that target instead of I don't know. I can't remember. Geez, I used to be all over the 16F84 like a rash.
It's like it's like these tool sets that people have. I still don't quite have this in my own. You know, I'm still like I don't have like a go-to, but like I mean a lot of hardware engineers specifically they learn Microchip. They're like it's just every time. Like Mike Harrison's a good example.
It just uses it for everything because
it's just this tool that he uses over and over again, and it's just
why not? Because you know it intimately. Why dick around with new tools? So I do micro stuff so infrequently. It's like, what do I use this time? I don't know. It's probably the same learning curve either way now, you know, because I forget.
It's either learning or relearning, right?
Right. Exactly. So it doesn't seem to make a difference. And as long as you stick with the vendor tools, you just install them, you write your C code and you compile. You know, there might be a few register, you know, tricks and other things between micros, but generally, you know, it doesn't take weeks to solve. You know, it takes like hours. You know, so it's not a big deal.
Yeah.
So
I have a lot of firmware. I was going to bring that up later. I have a lot of firmware coming up this winter, and I have some things that I'm going through for that. So,
right.
But let's get back to RF. So, what about RF? So, this is a thing. Is it aircraft or
aircraft transponder? Yes.
So on the actual airframe, like
yes. It's it's an instrument in the cockpit. It's an instrument in the cockpit. Okay. Right. Okay. So it's the transponder. It's your typical round instrument. So or virtually every light aircraft should have one of these transponder things. And there's a specific frequency, 1030 megahertz for the reception. So the air traffic control systems or other planes, they will like send out this 1030 megahertz pulse, right? And they expect, if you're in their airspace, they expect your transponder to return on 1090 megahertz, right? With the squawk code. And then when you fly into the air traffic control space, they will tell you, please set your transponder code so that we can track you, blah, blah, blah. So it's got a little dial on it and stuff. Anyway, transponder. So I did a teardown. Spoiler alert. And there's what looks like a there's a transmitter, like there's a big beefy ceramic output power transistor, which are specifically designed, by the way, chip of the week or part of the week. I can possibly hang on. I'll send you the data sheet for if I've got it. Do I still have one?
Is it like tuned? Yeah. Is it tuned to the actual frequency that like
it's it's not tuned because it's just a transistor, but it's optimized. Range, yeah. It's optimized for this thing. So I will send you. Here we go. There you go. Part of the week, and there's several of these, and it's a company, Gigahertz Technology, which I think have merged with somebody else now. But RF microwave silicon power transistors. That's all they do. And they've got one specifically for the 1030 and 1090 megahertz, transmission band, right? Yeah. So I don't know how you optimize a transistor for that particular thing. I don't know, but it's it's got an ultra high MTBF and
I would assume that it's something about like the dopants in the actual transistor so that it's resonating at the right the right range of frequency.
I wouldn't say resonating. I think you come a gutser on that term there, but anyway, if there are any silicon, Sharia would tell us, right?
Yeah, maybe we can ask Mr. Jeff Kaiser on Kaisermas, the upcoming Kaisermas. If he says yes, we actually haven't asked him. We just assume that he's going to show up.
But does he design, silicon?
Oh, he used to design RF power amplifiers. So.
Oh, okay, right. Oh, yeah. Okay. Jeez. But at the transistor, at the transistor, like actually designing the transistors themselves.
Yeah, that's
what
he used to do.
Oh,
yeah.
Okay.
Oh, yeah,
right.
yeah. Oh, he used to work at a chip firm. Yeah.
Oh, okay. Yeah. Right.
We'll ask him all about it on this year's Kaisermas if he shows up.
Yes. All right.
I'll message him later.
Anyway, there's specific transistors designed for these pulsed applications at just over a gig. I mean, we're sure you could use them for other things, but
so what's surrounding this thing? Like, what's actually driving this then? So is the PIC actually driving this FET like a driver?
Well, but the PIC's just like controlling the interface. It's got a 2-line dot matrix LCD. It's got buttons and other things, right? And there's not much in it. It's just basically the RF side of things is just a discrete 3 transistor power amp, something like at least, there's 3 of these beasties in there of different types. And it's, and it just drives the output, right?
What's the power rating? Because like
140 watts.
Okay, yeah, that's so like I'm just gonna say like I've been doing like some RF stuff lately, but it's like low power. It's
low power stuff.
RF-y,
this is like 140 watts.
Yeah, I mean that's like cranking.
Yeah, if you read the installation manual, it says do not install the antenna closer than 1.4 meters from anything else or something like that. It's like or humans.
You will cook your toe off. If you put this in the wrong spot, you will cook your toe into a Vienna sausage.
Yeah. Anyway, so there's a little antenna on the bottom, probably the backside bottom of the plane. That's the transponder antenna.
Cool.
Just over a gig. Yeah. Anyway, and of course, it's got a receive as well, using the same antenna. So of course they tap off a line from the antenna. So you're pumping out the 140 watts. It's mostly receiving all the time. It'll just only do a little, pulse transmit when it needs to, when it's requested to. It doesn't just randomly do it, just on its own. It's got to wait for a reception signal and go, oh yeah, okay, I'll transpond now. I'll send my code. And anyway, so it taps off the antenna output, goes through some control impedance lines on the Rogers PCB material or whatever it is, goes through a little distributed element filter on the PCB as well. I've done videos on those, which, use your tracers as your inductors, and then they use like large little pads which branch off, the funky RF looking things you see on PCBs, So they have a little like what looks like an LC filter there. And then it goes into what looks like to me, and I'm no RF expert, what looks like a comb line filter, right? And the comb line, they still which is an aluminium set of it's just a piece of block aluminium, right, or aluminum for you Yanks, right, with little fingers on it, and which then act as capacitor air gaps and stuff like that. And it's but the thing is, and then it's got little cavities in them where you can actually tune the things. So I'm not sure quite how they work. Anyway,
the comb line filter is actually like a separate element, you're saying, or it's actually on the PCB as well?
No. It's a separate aluminium block. But the interesting thing about it is, sorry, I can't send you a photo now, but maybe we can include it as the screenshot.
I mean, I'm looking them up as you're talking about this. So I didn't know this term though beforehand. So.
Well, okay, comb line filter. And there's many different varieties how you implement them. But this one is basically just a picture and aluminium thing with little fingers on it, right? And the signal goes into the aluminium, right? It's just bonded into the side. It's just got bond wires, and then it pops out the other side. But the interesting thing is that this comb line, this aluminium filter, is then just grounded, screwed straight into the chassis, which is grounded. Mm-hmm. Right? Mm-hmm. So you're effectively grounding the output of your power amplifier, right? It just goes into that. It still blows my mind.
Yeah, so it looks like you're like dumping it into a ground. Yeah,
it looks like you're dumping it into a ground, but at 1 gig, you're not, right?
That's right.
Because at 1 gig, everything
Skin
changes,
effects and,
right?
right.
No, well, yeah, it's just inductance and stuff, you know? Anyway,
inductance and stuff. Inductance and stuff.
It's a t-shirt there. Yeah. And it's just, every time I see something like that, I go, you know, like,
that sounds like the right response. Yeah.
It's not the right engineering response, is it? It's kind of, oh, I should learn that.
I think all engineering starts with wonder, and then eventually you go, I should learn more about this.
Yeah, exactly. If I could be bothered to, learn all about.
I mean, these power levels too. Like, I just don't deal in these power levels.
No, exactly.
Yeah.
Yeah.
I mean, because some of this, like the comb line stuff, like some of that is on PCBs sometimes, right? Like microstrip.
Oh, yes. Yeah, you can get comb line filters on PCBs, yes.
Right. And you've shown that, like when you do like VNA teardowns and stuff, you'll see some of that stuff, right? Or like spectrum analyzers.
Oh, yeah. Yeah, you'll see those on the PCBs. Yeah.
Yeah.
Yeah, but this one is like, it's screwed into the block. Like originally when I looked at it, I was all through my video, I've got to actually re-edit it. All through, I thought it was a cavity filter, which is a different thing, right? I thought the wire went in the side and it was insulated when it goes through the side, and then it's inside, it goes through the cavity, right? I thought it was a cavity, but it's not. The wire is just soldered to the piece of aluminium, which is then screwed into the bloody case with no insulating thing. It's just screwed into the grounded case. It's like, what the? Yeah. Anyway, comb line filter. I'm sure we're going to cop a lot of crap in the comments because,
I think we started pretty well with like, we don't know what we're talking about here. So.
No, exactly. Yeah.
And people probably start with a safe assumption of that.
Yeah. Oh, well, yeah.
Do you have interest in this otherwise? I think that's the real question is like, are you going to take this further? Because it would be interesting, like throw something like that. So like the filter, the comb line filter, is it like an SMA input or something like that? And then like, it's like a through pass?
No. It's literally a block of aluminium with a wire soldered into the side of the aluminium.
But is it a 2-port device or a 1-port device?
It's
like, there's nothing coming back out?
No. Well, no, there's a wire on the other side of it. Also wired directly through and soldered into the aluminium. So it's a piece of aluminium.
Right, but the signal's going through it, though. That's what I mean. It's like the signal's going through this thing.
Through, in quote marks. Right? It's like, that's the weird thing. It's like, it's shaped like a comb. So picture a comb, the bar at the top, the aluminium bar, and there's a wire, and it's got all these little fingers coming down, and there's a wire that goes into the first finger and a wire that comes out of the last finger. But if you put your multimeter on it, of course, it measures 0 ohms because it's just a chunk of aluminium.
That's right. Yep.
But it, and it magically just, like the ones you get on PCBs, like they might be isolated, of course, right? They're not actually grounded, although that might be the definition of a comb filter. So anyway, I won't go into details because I can't.
Yeah, I was just wondering, like, if you put it on a VNA, what it looks like, that kind of thing, So like looking at the actual impedance of that thing would be interesting.
Yeah, it's just fascinating. It's a block of aluminium. Like I could understand if it was like insulated from the chassis, and it's just sitting there and it's just a block and it's, okay, right? I know, but the fact that it's just screwed into the chassis and it's grounded and it's hooked practically directly to the antenna via a PCB trace. It's like, well, oh man, it just weirds me out. That's all. Yeah. So I think I'll stick to digital, low power stuff. Thank you.
Okay.
End of story. Yep.
Okay. Well, we have another thing on the list about RF stuff. There's apparently there was a test on the Pi 4, which is like if you're on the Ethernet, you can actually It was actually was it 375 megahertz, I think? Yeah. But this thing was
Right.
actually like, the Pi 4 was like just cranking RF energy out of the Ethernet port.
Right. That's interesting. Well,
Yeah.
technically, is that classed as conducted mode radiation? Because it's
I don't know.
conducted out, even though Ethernet is technically isolated because of the transformer. Oh, there's another tricky question for our RF aficionados. Is it conducted? Because there's two types of radiation. There's conducted mode radiation, which radiates out of the wires that come into and out of your device, right? And technically, that's what's happening here, right? But usually, by the term conducted, it means electrically conducted via the shield, via the the power wiring and stuff like that. Whereas Ethernet is technically isolated. So I think I'd still call it conducted mode.
Here's the thing. So like if you watch the video, it's basically just a Raspberry Pi attached to a battery hanging out in space, and then he's got a radio across the room that's receiving.
Oh, right. Is that all? Okay.
Yeah, it's receiving signal from it. So.
Oh, okay. Oh, so he hasn't even got an Ethernet connected to it.
No, it's not actually the case. It's through the actual, the Ethernet PHY basically is cranking.
Oh, okay. So it's not even, sorry, my little roundabout conducted mode interference is totally worthless there. Yeah. Okay. I just assumed it would only do it, when it has
you meant like actually over the
cable hanging off. Yeah. And then the wire acts as the antenna. That's what conducted mode interference is.
Right. Yeah.
Yeah.
This is crazy.
Wow.
All right. And one last thing, since we're in the RF mode, and this is maybe another good question for Jeff. We talked about it here, but I have no idea what's been happening. So I had to stop recording on my H6N, which is like a recorder, right? So it basically is how
portable thing. Yep.
Yeah, it's a little portable recorder. It does XLR inputs and stuff like that. And so I have in my setup downstairs, I have like a microphone that's a shotgun microphone, and then I have a cable going off that. And sometimes I would use lapel mics off of it too, whatever. But and I live in downtown Chicago, so live pretty close to like a huge transmitter known as the Sears or Willis Tower. And like, but if the wires are configured just right, it picks up not even just right. It's like all the time because it's, we're pretty close. And like it conducts. It will start playing a radio station, and it sounds like an FM radio station just from the content. I haven't been able to match up with which station. Like it would make more sense if it was an AM station, just because it's like
because it would be bridge rectified, because then you can have it just purely AM rectified. But FM requires demodulation of FM.
Exactly, and that's where it doesn't make any sense to me. I probably should just investigate it more, but like it leaks into everything and here and it's
we've had this on the show before. Weren't we almost borderline going to like drive out to like near a transmitter and try it somehow? Didn't you? Well,
I live near a transmitter. I mean,
you said, "Oh, take your Zoom, out there near the transmitter and try it." Have you actually verified that it is an FM station?
And that's the thing I haven't done. I really should do that because otherwise,
I think you need to do that.
But it's all like music and like just there aren't many AM stations that play music these days. Just because like why would you?
Right.
So
I don't know.
Yeah, I should actually try and match it up with the station, but
because if people don't know, like a crystal radio set is the classic way to pick up an AM radio signal, right? They did this in the trenches in the World Wars, right? They they crafted together radios out of a razor blade and a pencil. That's literally all you need, right, to make a point contact diode, and you can whack it onto an antenna and put in a crystal earpiece, and bingo, you can actually pick up signals, right? It's called a crystal radio. And there's lots of things that can actually form parasitic PN junctions, i.e. a diode. And then once you've got a diode in there and a long antenna, you're picking stuff up, right? And it's being rectified. And it's,
Yeah. And that's why it would make a lot more sense if it was AM. But
right.
I didn't think it was. Anyways, I should really, I should verify that first because that makes a lot more sense.
Fascinating. Wow. And annoying.
Fixed it by changing the cable length. If you didn't know that,
cable length. Okay, and fix it. You get in alfoil and
No, not that. I mean, that's not going to help much. But I mean, because this is basically, I was like had a huge antenna because it was just like a a 6 meter cable or something like that. It was just extra cable I had, and it was like at the right frequency. So
You need to move out into the burbs, my friend.
I know. Well, yeah, I gotta. I have wondered about that too because I have like a bunch of like spurious noise on scopes sometimes too, and like being near. Some of it's beneficial, right? I mean, like I can hit a cell tower like 3 blocks from my house when I'm doing cellular stuff, but
right.
when I'm just like trying to like pick up, when I'm like looking at like a high bandwidth signal on my scope and I start to pick up all this other noise, I'm just like always questioning like, is it some kind of localized RF that's getting rectified into this stuff? So
you could be chasing your tail, think you got no problem in your product, right? It's you've got to be careful. So you may actually have a problem in your product. As I said, some parasitic diode junction somewhere in some long cable that could be a problem with your product, but it only manifests itself under certain configurations.
Right. And on the one hand, you could imagine it'd be good because it's like, I'm going to find that problem early instead of like, if I was like in the boonies and I was, developing a product and I'm like, oh, this thing works great. There's no interference around here. And then if I drive downtown, I drop it off at a customer and they're like, no, this doesn't work at all. So I guess from that perspective, it's good, but it's a little, still annoying. Right. Just trying to get my scope to work, man.
Oh boy. Yeah. Can we talk about dodgy wiring? I've got a segue with dodgy wiring that I tweeted this morning.
Yeah, I saw that.
Yeah, I got a new aircon installed, or she who must be obeyed did. Got need another aircon for them because she's working from home now, right?
Sure.
And then we've got a new back room where
and it's hot as hell in Australia right now, so
and it's coming in summertime. So she said, "Well, I want a damn aircon," because we've got aircons in other parts of the house, but it doesn't sort of bleed. Because we don't have like central aircon. Whatever.
That's right.
So anyway, they installed, the tiniest one we could get because it's only suitable for one room. So it's a 3.5 kilowatt aircon, which of course doesn't mean it draws 3.5 kilowatts, right? Because the coefficient of performance, aircons are heat pumps, right? So technically, like a 3.5 kilowatt aircon in this case supposedly only takes 800 watts, right? So the coefficient of performance, you divide 3.2 by 0.8 or whatever, and that's your coefficient of performance, right? But there's other peak surge figures involved and stuff like that. I can't actually make heads or tails of the label.
It's like the max rating. Is that kind of the idea? So that's just like you can size it, like that would be the absolute maximum output?
The label's got two things. Have a look at my, if you're interested, have a look at my Twitter photo, which we'll link in to the show notes. And you can see there's one table for the unit itself, but then there's another one, which if you look up the model number for it goes, it's only 0.8 watts, 0.8 kilowatts power consumption, right? For the 3.5 kilowatt model. So which one, so I think it's the 0.8. Anyway, what they did is they wired it. Like I just expected them to install a new fuse in the box, right, and run another dedicated cable because I thought, aircons, they draw a lot. I didn't think about, how much it actually drew, even though I knew it was a small one. And I just assumed. So I went out to the box to check that they've installed the new fuse and everything, and there's nothing there. So I went, how the hell have they wired this thing in? And I tried checking out the other switches. I thought, maybe they shared it with one because we've got two other aircon, circuit breakers. So I thought, maybe they've shared it because it's a low power one. Or whatever. And no, I tried that. No, it's still working when I disconnect the other fuses. So I went, these bastards have wired it.
What's it hooked into?
These bastards have wired it into the mains, into the power points. They must have. It was the only option. So I went up in the roof.
Like one of the local, so you mean like one of the actual plugs on the wall near it or something?
Well, the wiring that goes to the power points in the wall, right? Yeah. So, and it's sure enough, I went up in the roof this morning and sure enough, I took a photo. There it is. It's wired spliced into the existing PowerPoint wiring. And I just assumed that wasn't legal to hardwire a device like an air conditioner into a PowerPoint wiring.
Yeah, I mean, this would be like the equivalent of plugging so like I actually am staring at an air conditioner as well. And we have a dedicated circuit for it. Because it's like a heavy duty, but it is plugged into the wall in a, so the US has that dual phase.
Right.
Thing,
you can have it. Right.
That. Yeah. So it
plugs in. Yeah.
Yeah. It's its own circuit, but it does plug in. Yeah. And I mean, you could do that for a window unit too, if you had a window unit to put into.
You could probably plug it in, but this one's a fixed device. So I believe the laws are different for anything that's a fixed wired device. Please correct me if I'm wrong, because I don't know my code, It's all about the specific. So
what do you call it? It's the NEC here, the National Electric Code, I think.
Actually, yeah, it's something else here. I don't know what it is. It's, some standard here. Anyway, it's very, it's like a 300-page book or something, isn't it? And, if you want to become a Sparky, that's what you have to know inside and out, right? And I just know absolutely nothing about it. So I don't even know if that's legal or not. But I guess if it is, I'm going to have to measure it. If it is actually drawing only 800 watts, then technically that's just like plugging an 800-watt microwave into the power point, right? It's not a big deal, but whether or not it's technically legal to do that, I don't know. So please leave it in the comments if you're a Sparky certified in New South Wales.
Right, exactly. And it is a local thing too, right? I mean, you really should just talk to them. Yeah.
Oh, totally local. Yeah, I'm sure it varies from state to state too. You could probably have different. Yeah, I could be wrong on that, but that wouldn't surprise me at all. Consider that we have different legislation requirements, registration requirements for different states.
To be like called an electrician.
Yes. Well, what you have to go through to become an electrician in different states is different. It's all state based. So so that wouldn't surprise me at all. But there's probably some national code for it. But I don't know. I just thought that was like dodgy. I just but it may not be. They may went, well, it's only, if it does draw 800 watts, only 800 watts was whacking into the existing 20 amp wiring, for the power points. But I don't know. I was just like,
I mean, maybe they can calculate the load on the total circuit or whatever. But
well, that's the thing. Like technically, each outlet is 10 amps, right? And yet we've installed how many power points in the new back room that has the new wire in there. Right, there's like, I don't know, 8 power points or something, right? So you can't put 10 amps into, you can't draw 10 amps from each one.
Have like 3 vacuum cleaners running in there.
And a fridge and a microwave and a hair dryer and a right. It's just going to go.
It's a busy place. It's a busy place.
Yeah, exactly. Like on my bench here, just the bench I'm working at now, I've got 20 power points. I believe that's the maximum you can install on one circuit. So anyway, so please, I need to know, is that dodgy? It just seems a bit, how you doing? So anyway, what else we got?
Well, we could stick on the RF side of things if you wanted to. We could stick on the RF side if you wanted to, because there was a teardown of the Starlink. We talked about the Starlink when yours was on the show last week. Last week? No. Yes. Basically we talked about, that was Michael last week. So 2 weeks ago when yours was on the show, we talked about Starlink a little bit, and then he actually sent me a link that was about someone did a teardown. They took their early Dishy, which is called that's the thing in that. So it's kind of cool.
Our former guest and friend Robert Feradek, who runs the excellent YouTube channel. And runs the PCB courses. That's and everything. Yeah. He's just done a video. Which PCB design software is the best? The top 4 are.
This was a clickbait.
It's clickbait. Did he give any conclusion? Because he's an Altium man, right?
Well, but he's basically said the right. Sorry, spoilers. But he said the right one is the one that is the right for you.
It's the one that's right for you. Yes, well done, Robert. There's a golf clap for the for the clickbait. Yep. And it's probably going to work. And oh boy, I think that's like he doesn't mention Eagle, does he? He doesn't mention Eagle. He doesn't. Altium, Cadence, KiCad, Mentor.
Yeah, but that might be right for some people, So
see, 10 years ago it was Eagle was gonna, and nobody talks about Eagle anymore. It's just Gonski.
No, some people do. I mean, first off, Eagle is going away. I mean, it's going to be called Fusion 360 Electronics or whatever they call it.
Okay. Yeah.
That's what they're migrating it to, and there's going to be people that are upset about that, I'm sure, but
sure. Yeah.
It's I don't know.
Yeah. No, I think KiCad has just absolutely buried that now. So Yep.
You do any boards these days? Have you done a board recently?
No, I haven't done a board recently. No, unfortunately. No.
You should check out. Why? I just started using. I've been doing a bunch of VM stuff lately, and I was looking at a design that was done in version 6 of KiCad, and it was interesting. Just like, that first time you open, it was almost so, not so different, but it was different enough that I open it up and I'm like, oh, what am I doing here? Like I just like got lost immediately. And you might want to check out the new one. It's getting closer to an Altium kind of thing. So.
Oh, okay. So they've totally revamped the UI again, have they?
Not the UI, but like some of more of the features, and like it's all scriptable for. So like one of the lacking in the V5 was kind of the individual nature of DRC. So that you couldn't like really specify DRC to like the same level that like an Altium or
Right.
an Allegro or whatever could do. And now it's all like scriptable even, which is kind of
okay.
pretty cool.
Right.
So yeah, that part's. I mean, it's a lot of like so like we did a developer chat a while back, which was like the replacement for KaiCon, and they talked about like John Evans and Seth Philbrand and Wayne and the whole team, like they all kind of went through all the different things that are out there that are going to be different on there. So I'll link that in again. But
right,
yeah, I was just wondering if you had opened that up recently and seen some of the new designs. So
unfortunately not. I'll have to check it out.
Yeah, it's good. I do like this new method of so I've been doing like VMware boxes for like each client. So like a VM basically. So each time, all the tool chains in there, I have a KiCad instance in there. It's just kind of like a standalone thing. Then if I need to, I can just like box it up and ship it over, and it's like sending them a laptop. So that's the new method of doing things. So because I've also
that's rather professional of you, Chris.
Yeah, I mean, I think the real thing is that I had to refirmware the computer and I lost a tool chain, and I was like, oh, this
right,
this sucks. So I should just do this better, So yeah.
Oh boy. Yep.
Yeah.
All right. Nice. Oh, speaking of PCB designs, Greg Darville on his Twitter has been doing an Advent PCB every day. So if you want to follow him on Twitter, I don't know where he gets the time to do a PCB every day. Like, and some of them are, like just is like madman.
Yeah. He's a mad lad.
Mad lad, as the pobbies call him. Yeah.
Yes, that's right.
Mad lad. Is that a term in the US too? Mad lad?
No, I mean just on the internet.
Right.
Quoting British people, yeah.
Yes, yeah, exactly. Mad lad. Absolute mad lad.
Yeah, there's another Advent thing too. I think this is kind of like a popular thing. I've seen one for like 3D stuff. There's also one that's Advent of code. So like if you wanted to so there's like an Advent calendar is like a Christmas tradition type of thing. It's non-religious, all this stuff, but it's like a thing a day
for
like a month. Yeah. Yep. And so there's one for code as well that's going on. So it's it's the third now. You could still get into it though. It's called adventofcode.com. So that's another one you could do. It's a good way to like kind of follow along, follow other people, kind of push yourself to do a thing. When I talked to Sophie Wong on the Contextual Electronics podcast, she did one which was like 30 days of fusion. So she was learning 3D modeling. I thought that was a great idea too. It's like just a good way to push yourself each day. And even if it ends up becoming something where it's like that day is not like the most, it doesn't have to be
it doesn't have to be
best
good
thing on a day, but it's just getting the
it's doing something
down and doing something. Right. Exactly.
Yep.
There was I think it's in the one of the books I like, Atomic Habits, I think, maybe one of the other books. There was like this anecdote about like a photography professor, and they talk about like he split his class into two, and he said to one group, you get judged on how many photos you do. You have to do at least 100 photos in the semester. And then the other group was you get judged on the quality of your best photo. And the idea was like comparing those two.
Yep.
And I really like that because the quantity group, they didn't have the best photo. Every photo is not the best photo, but because they iterated so much, they just like they outshone the other group like crazy because people weren't like really concentrating on that one thing and like perfecting it. It was more just like, just try a bunch of different things. So
churning it out. And eventually you're going to hit on a winner, right? There's going to be one in there that's absolutely spectacular, or just as good as you could have done when you carefully planned it and, set it out. It's like, everyone's used to that. When you take photos, you go on a, a holiday or something, and there'll be one or two spectacular photos that just happen to turn out. And the rest are just meh,
But you still make people sit through the entire slideshow.
Entire slideshow. Yep. Yep. I can remember when I actually produced a DVD of our world trip, and then you'll make the family members sit through.
You didn't. Did you ever do slides? You ever do actual slides?
No.
I always
So,
wanted to, but I never had like a carousel, like you had to actually
right.
have like a
No.
projector carousel thing.
We
So
we weren't a camera family. Technically, we had a camera, but there's so few photos of me as a kid, like of our
yeah,
family actually growing up. There's like I could count them on both hands.
even like a
Like
handy cam, like a point and shoot kind of thing. Like those were like getting popular as you were growing up, right?
no. What? Wait, you're talking about a video camera?
No. Sorry, like the 35 millimeter, like a handy cam, like probably the wrong term, but just like the 35 millimeter, you throw like two batteries in there and it's self winding and
You're talking about a compact. Yeah, no, you're talking
yeah,
about a
exactly that
compact
kind of
camera.
thing. Yeah,
No,
yeah.
we didn't. No, we had some ancient thing,
Got it.
and yeah, no, I probably wasn't until mid '90s that I got a film camera of my own.
Yeah.
But that's beyond being a kid anymore. That's
Yeah, of course,
like
yeah.
yeah,
Yeah,
or
that's like
maybe early '90s or something that I actually got.
Dave decides to try photography, right?
Yeah, it's like
Yeah.
I got one of those compact things, and it had the little LCD on it. It had all the various it can measure distance, and it had the infrared to measure the focus distance automatically, and all that sort of jazz.
Yeah.
And I think it was a Pentax. Oh, there you go,
Yeah,
for all you Pentax
yeah.
fanboys. And and no, but when we were a kid, no, it was like no, we just didn't take photos. It's like technically, yeah, we did have this film camera somewhere gathering dust, but no, just
Right. Yeah.
So yeah,
The
don't
cost
ask
of
me
doing
for
it.
photos of when I was a kid. There's like I can maybe pull out a couple, but that's it.
You heard it here first, folks. Was Dave
Yep.
even ever a child?
Child, yeah, no,
We don't know.
no, yes. Ah, boy. Anyway,
Yeah, so firmware. I realized that all of my all of my projects are like coming like I'm doing all these assemblies and stuff like that. And like between okay, so first off, news flash to everyone out there. Chinese New Year will be happening again this year. It is the first week of February, I believe, and it's coming towards us. So get your designs
prepare
out
now.
now. You
Yep.
think about it now, and so I've been thinking about that, and I've been like kind of like doing the math and like, okay, well, I should, I got about a month, a month and a half to build and build my own, or I could still get parts from DigiKey, or I could get some locally sourced boards, whatever. But it's just like that's a pretty big schism in the electronics world, and so it's like I'm gonna have everything built by then. But then it's like, oh man, like that means a good portion of the winter is going to be me doing firmware, and it's like,
Right.
oh yeah, just kind of like that mental shift is like I don't know, maybe I need. So I've been thinking about like how to get better at firmware, and I've been asking online and things like that. And obviously, there's just a wide variety of people giving advice, and it's very much appreciated. But it's a lot. So I'm reading new books, Dave. I'm sure you'll be surprised to hear. I'm reading new books. I know. Yeah. Yeah.
Can we shout out again former guest Bunny, who's done another just incredible blog post about the Precursor is his new. Is it it's not really a phone, is it? But it's a mobile device with an FPGA in it, and it's a. Anyway, it was a Kickstarter, or still is a Kickstarter or something. The Precursor. Yeah, something like that. Has he met his target? Because last I looked, it wasn't.
He is not. He's at like 180 out of 220K. So I bet he'll hit it though. I bet.
Oh, that's agonizingly close, isn't it?
Yeah.
Yeah. Anyway, yeah, the Precursor, and he basically this is a blog post about the custom PCBs in there, and everything to do with manufacturing detail of these custom PCBs. He's put together all these micro photos of the via, of the section, the cross section of the PCB, and matches that up with the PCB layout and stuff. He's gone to a lot of effort for this blog post, so it's well worth reading.
Yeah, there's a lot of stuff in there it's kind of like if you're on the edge of like using, maybe the prototyping services and like that, and you're thinking like, oh, I want to push the envelope of my own designs and get to, get to higher, like he talks about, you just literally can't use some of the parts that are out there these days that are like 0.25, 0.4 millimeter pitch BGAs. You just can't get the stuff out of those parts.
Can't do it on a standard $5 proto board.
Yeah, exactly. And so he's using like laser microvias and stuff like that. And he shows a stack up and how that impacts things. And then he talks about the inverted F antenna that he's using for 2.4, which is also the logo on the bezel, and it's just like it's super cool.
Yep.
And so Bunny's been on the show twice before. We might try and get him back. We'll see. but he's working with Zobs as well, who's also been on the show. And it's always interesting seeing. So like the precursor is, I think, tied to his work. He worked with Snowden for a bit.
Yes, he worked with Snowden on the secure phone thing.
That's right. That's the focus of this as well.
I don't know if that ever became a product though.
I don't think so, but I think this is not an offshoot of that, but I think this is the same. This is so it's security first is kind of the precursors kind of thing, and basically knowing everything that's in your phone, and they're going to eventually do custom silicon. They have FPGAs on board, and so Sean had worked on he did the FOMU, and so he's been on the show before talking about the FOMU, which is the tiny FPGA board that also has the open tool chain that Tim Ansell's been on the show before about talking about. So yeah, so they're doing really cool things about like knowing this is kind of like a know your device top to bottom, kind of like this is like the handheld communicator version of the Novena, right? Yep. So the Novena was the laptop that they also worked on and talked about on the show before. It's got all these different elements on there that are meant to be like super high trust, super secure, and then as a basis for building that next thing. I think that's why I think they explained at some point about why they didn't put a cellular modem on there, but I think it was also because like you just can't get access to the silicon and trust it enough that it's not,
right.
Diving into your data kind of thing. So
sweet.
Yeah. And it's, it's got a nice keyboard. That's fun.
In other news, can we do a news? News. Can we have a?
I'm still a little bummed you didn't have more questions for me about firmware. To be honest, I thought you were gonna I don't know, you just don't want to talk about firmware at all. No,
okay,
no. All right, that's it. I'm going embedded. I'm going to talk to those folks about it.
You're fine. You can have them. You're surprised that I didn't want to talk about firmware?
All right, fine. We'll talk about. I'll talk about it on the other podcast too. And,
if it was 20 years ago, I'd be talking.
Trying to engage you to talk about, be like, oh yeah, I should really do some firmware.
No, it doesn't excite me.
It's not fun. Honestly, I'm a little scared about it. I'm a little, it's a lot of, getting better.
No,
but it's,
Yep. No, okay. I'm not that excited. Sorry.
All right. Well, that's fine. That's the thing. So I also think about this. So and we can find realms of electronics that are firmware free, right? Or firmware simple or all these other things. But I just, from a work perspective, from a things I want to build perspective, I just can't get away from it. I don't, and some of it is of course, because I'm dealing in IoT-ish type things.
Of course. It's impossible. It's the field you're in. No, there's other fields. You can go your entire career without touching firmware.
Right, exactly. I mean, and especially if you specialize too, some of the analog folks that I knew at Keithley, or when I was doing some of the analog stuff at Keithley, it's they were just 30-year analog veterans, or RF people that were just 30-year RF veterans. It's just I want more, Dave. I want to do more of it. So, all right. Anyways,
knock yourself out.
All right. So, what's the next thing you want to talk about?
Can we have a moment's silence, please? It's not electronics related, really, but
okay. No firmware, but let's talk about something else.
Exactly, totally. Why not? You get to indulge your firmware fantasies. I can indulge my space.
It's not really fantasy so much as life, but yeah. Anyways, this is
space
moment of
and
silence.
Astronomy and moment of silence for the Arecibo. Radio telescope. Did you see the video? They actually had drone. I just saw it this morning. They had drone footage. They happened to have a drone in the air when the thing collapsed.
Yes, I did see it because I think you retweeted my retweet. So.
Yes. Did I retweet? Oh, you're right. But I don't know. I was just in a hurry this morning. I saw it on my Twitter feed. I don't know who I was retweeting.
Yeah, it's pretty cool though. I mean, there's another view of it too, where there's a view from the ground where you actually see the entire thing.
Really? Okay, I haven't had a look.
And if people don't know what we're talking about here, this is in Puerto Rico. This is better known as the site of GoldenEye, when the last scene where, James Bond's running along the pathway out to this thing, and it's supposed to be controlling the GoldenEye satellites. Yeah, that's the popular culture reference, but but the actual thing is
it's also in Carl Sagan's Contact as well.
Yeah, right. So why don't you explain what the telescope is, though, if people don't know?
Oh, it's the world's biggest radio telescope. It's built into a natural divot in the ground, right? I can't remember the exact width of it. It's was it 300 meters or something? It's absolutely enormous, right?
It's huge,
There's no way you can build that big a dish without, building it into the ground. There's no way you can have it up on a pivot point and then pivot the thing around, right? So what they do is they built the big dish into a natural crater in the ground, and then they've got these three gigantic cables that come over for the receiver on top and or transmitter, right? And then that's the thing that moves. Like normally you steer the dish, right? But because this is a fixed dish in the side of the mountain, you can't steer it, right? So the way they steer it is to move the it has a name and it escapes me. We've both been there. We've both been to the Canberra Deep Space Network, so we should know the name of the thing at the top, the head, bit. And so that's what they steer, right? So there's giant cables that can move the head around so that the focal point is different on the dish, right? So that's how they steer it.
Right. This is your algebra class, right? Of like parabolas.
It's a parabolas
like
and
geometry.
all that.
I don't even know. It's I guess it's geometry, but like the parabola.
I think it's a Cassegrain.
Oh yeah, interesting.
Anyway, I could be totally ballsing that one up, but anyway, it is actually the world's largest radar transmitter as well. So they actually do radar imaging of asteroids and planets and stuff like that. They can actually get ridiculously high resolution radar maps of these 1 kilometer wide asteroids, and stuff like that. It's the only dish in the world that can do it. Anyway, it was built in like the 1960s, and basically they cut the funding by like 90% of this thing, and so they couldn't maintain it. The time to maintain it was like a decade ago. They were screaming out, look, this thing needs maintenance. It's a big, huge mechanical beast, right?
Right.
These giant cables. And no, one of the, and it famously, like, I think a couple of years back, there was some damage to it or something. It's been having problems over the years. And then like 6 months ago or whatever, made all the news because, one of the part of the superstructure of the dish actually collapsed or whatever.
Yeah.
And now they just released a report last week saying, sorry, it's too dangerous to even try and repair it now.
Right. Like, how would you get near it without it, like, knowing it's not going to snap or whatever?
Yeah, knowing, and these cables, they're all fatigued and they're measuring the loads on these cables and they're going, shit, this is like, the load is like twice what they're designed to take. And then as one cable snapped, it put extra load on the other cables and stuff.
Yeah.
So, it's just, but what a great call that the team who evaluated this said, no, it's too safe to even work on it. Right? It's too unsafe to even work on it. And sure enough, like a week later after that report came out, it collapsed. The whole thing, the cable snapped and it actually pendulumed or something. I have to watch the video again. I haven't.
If you look at, I just dropped the link in the closer one or the better view. So
right. Yeah. Okay. All right. Here we go. Let's have a look. Hang on. I'm watching. Oh, look at it. Whoa. And it pendulums. Yep. It pendulums on the two cables. Yep. And then one of them snaps. Oh, wow. Yeah. Wow. Oh, and the tower went too, did it? One of the towers.
Yeah. One of the towers. Yeah.
Wow. Wow. I'm retweeting that one now. Retweet.
Yeah, I mean, there's just a lot of failures
that's insane.
Happening at once. It's a lot of,
But the interesting thing is apparently what triggered it is an earthquake. There was, it can't be a coincidence that they actually time correlated an earthquake. It was only a small little tremor thing, right? But apparently these cables were so old and so overloaded that that's all it took was one little vibration and it just boom. And it just, it snapped it. Yep. So, wow. Yeah. Wow. And everyone wanted to save it, of course. Why don't you save it? And they went, nah, sorry. It's too dangerous to even work on.
Well, what about like because there's the square kilometer array right down in South Africa?
And
too?
Australia has a square and Australia has a partial one.
That's right.
Which is the Murchison Widefield array or something it's called. Yeah.
Yeah, I mean, so you're talking about like some of the functionality is specific to this implementation. So it's like, you're not going to replace that, but some of the coverage they are going to be able to get otherwise, right?
Oh, yeah, for some things, but other things like radar mapping. This is the only dish in the world that could map high-power objects with objects with high-power radar, I believe, anyway.
Yeah.
So, at this sort of scale. So, and I also tweeted out last week when the news said that they weren't going to fix it. I did the comparison. I did the calculations. You can build 5 or something, 4 or 5 brand new Arecibo telescopes around the world for the price of what Virgin Hyperloop were wasting on their stupid new Hyperloop center.
Your favorite topics, yes.
Yeah. That's
but Dave, how do you sell that? Is a
I know you can't sell it exactly. It's a hole in the ground with
is that as sexy as a vacuum tube with?
That's not
rich
as sexy as a vacuum tube with rich people shooting through it. Yeah. Which is not going to happen. So yeah, that's going to be $500 million wasted. So
yeah, totally.
Yeah.
Yep.
Anyway, so you actually agree with me? You agree that Hyperloop's bunk?
Yeah, I don't have a hot take on it, to be honest.
Right. Okay. Right. It just the vibe, huh? The vibe is like,
I mean,
you're not going to get me in a 200 kilometer long vacuum tube.
Oh well, okay. So actually, when Rahm Emanuel was like the mayor here, it was like here in Chicago. That was like one of the first spots they were talking about, like going from downtown Chicago out to O'Hare, which is like a 40-kilometer distance or something like that. It's it's a long drive for rich people that are in the city that want to go to the airport, kind of thing.
They did this in Singapore. Shanghai. The Shanghai Maglev does that.
Yeah,
30 kilometers to the airport. Yeah,
right. But everything's built out here, and there's no way they're going to eminent domain like all an actual train. There is a train line that goes there. It just takes an hour from downtown.
Forever.
Right?
Yeah.
I mean, like they should just put there's just no way to do a express line, and so Elon came to town and he was talking about, we could dig under the town, and it was just big news silliness here. It's stupid though. Like Chicago can't afford anything, let alone a freaking tunnel.
Exactly.
And it's just such a quagmire that I'd take a lot of these things with grains of salt, and like I'm sure they're gonna build one at some point, but like, is it worth it?
No, it's
probably not.
I will go on record as saying there will not be a functional one transporting humans. You might get some stupid thing. Yes. I just think the number of engineering. It's possible. You can do it. Right. But if you just look at the engineering involved in it, it's just ridiculous for the benefit you get. Just put in standard maglev, right? It's just, there's just not enough advantage for all of the problems that go along with it. There's just, it's not 5 times faster, right? It's in fact, it's not even twice as fast, right? It's it's borderline twice as fast, right? So it's twice as fast as regular maglev, right? But not as high-speed trains. High-speed rail is even closer than a maglev at the moment. But anyway, let's say it's twice as fast, right? Okay, but
the cost is
it's not just the cost, but not only the cost, the safety, the maintenance, and everything else that goes into keeping a low-pressure vacuum system like that for 100 or 1,000 kilometers, right? That's insane enough. But the fact that then you have to go through all these airlocks and stuff like that, you have to go through an airlock, then you've got to pump out the fact that all this takes time, right? So all this supposed high speed, and then you got to get up to speed, right? So I actually calculated that you need, like, I've been on the Shanghai Maglev, right, at 430 kilometers an hour. Right, that's how fast it goes. Right, but you only get to do that 430 k's for like a minute, right? Because you have to accelerate up to that, and you have to decelerate, and the limit of that is human endurance, right? People don't want to be uncomfortably shot off at 5 Gs, right?
I know all about that from science fiction. You listen to some hard sci-fi, and you're gonna learn that halfway through the journey, you turn around and start decelerating, at the same rate.
Yeah, exactly. and so that's the thing. So all the time, right? So all that supposed extra speed doesn't gain you much advantage, especially when you've got to go through airlocks and safety procedures and all sorts of stuff. Whereas the Shanghai Maglev, it just turns up, you hop on a minute later,
and it's bigger, and
it's just bigger. It carries more people, and it's a proven existing technology. I mean, what is there for twice the peak speed? No, it's dumb. It'll never happen. It's money it's money down the hole, guaranteed. And their new center, their new development center, their new R&D design center.
No. You got to shut down firmware. I get to shut down this thing. We get it. Like
nowhere. It's just no. No. All right. Enough Hyperloop.
All right.
I just wanted to go on the record as if I haven't on the show before.
You have on Twitter. I've seen it on Twitter.
I have on Twitter. Yeah, I don't think I've done a video. Oh, maybe I've done a partial video. I've done one Hyperloop video on the second channel. Yeah. Anyway, okay. Consider me shut down.
Okay.
I'm powering.
I don't disagree with it. So.
Oh wow!
We're on the same side
which
here.
is a shock. I'm absolutely stunned.
I think it's a good logical argument. I think it's just okay.
Yeah, right. But you haven't. You don't care about the details. You just go.
Yeah, that's the thing.
Probably not.
I mean, here's the thing. I live in a city that's so like backwards in terms of just like getting construction done, just like regular road construction. It's like, I look at China. Like there was an animated GIF of a train, like a maglev train, and there's like a Kane Shea, he does old machine picks the Twitter account, and so basically it's like these amazing industrial processes and all these things that are like animated GIFs of that sort of thing. And so but there's one where there's this train element that comes and like basically lays down it can extend itself and like cantilever it so that it actually gets to the end of a bridge that it's building effectively.
I retweeted that the other day. Yeah.
Maybe I saw it from you then. Yeah.
I think you probably saw it on my timeline. Yeah, it builds its own bridge.
Yeah, but that is so far out of like the capabilities of like Illinois building and like funding and like just there's so many layers in between that I'm just like it doesn't register for me. It's like it's like someone being like, oh well, you can get 5G on your new circuit board, and I'm like, I am just trying to get an LED to blink, I'm just trying to buy some PCBs here,
Well, if you want to make stuff happen, just go for communism, knock yourself out, and it's easy then, right? Right. Good luck.
Yeah.
Yep.
Right.
The Great Reset. Yes.
Well.
Sorry. Yeah.
Speaking of parts, though, have you been noticing that?
Speaking of parts.
Well, I was talking about LEDs and trying to pivot away from you talking about communism and
the Great Reset. And come on, I'm going to drag you into it.
No, you're not.
No, all right.
But
all right.
Supply chains are just like out.
Oh,
like crazy.
I do have a proper segue for that.
Okay. I'll take whatever you got, Dave.
Yeah. Okay. My latest rant video, right? I bought this new DJI Pocket
thing. I saw that
2
thing. Yeah, no, that's not related. That's a firmware thing. You didn't want to talk about when we talked about firmware.
No, it's not a firmware thing. It's a paradigm change. Like I bought a camera and the camera stopped working after 5 uses.
Yeah.
Until I actually install their spyware app and register it and provide all my details, then my product that I paid for will start working again. It. Right.
So this was not tied to supply chain. This is tied to China.
Oh no. This is this was tied into the whole Great Reset thing.
Got it.
Yeah.
Okay. Yeah. So you're trying to just drag me into that still. You just don't want
to. No. I'm not trying to drag you. I'm trying to drag you more into the side of no. This is the way products are going. Right. This is the way that they're going, and this impacts all of us. Right. Is that like you don't buy things like you don't buy and own something anymore.
I don't buy stuff from DJI either, though. Like
no, well, that was the first time I ever did, and I didn't give it a second thought. I thought, I'm buying a camera; it saves video to the SD card, and that's it. It's like, I might have to plug in the USB if I ever update the firmware. That's a thing, right? But no, it literally stopped working and bricked itself after 5 uses until I've got no option.
Yeah, you gotta hook it in.
Yeah, no, it's bullshit. It's like,
well, send it back. I don't know. Like, don't support that.
That's what I'm doing. Yeah, a lot of people said. A lot of people said, do a video sledgehammer in it. Widlerizing it. And I thought, well, that doesn't send them a message. If everyone sends this stuff back, then that sends a message.
Yeah, I mean, I think that cheap so I see a lot of cheap hardware out there, right? There's a lot of cheap hardware in the ecosystem. Some of it is just because it's designed to be low cost. But if it's cheap and you don't know why and it does crazy things for you, it's like, oh, okay, well, where's the money really coming from for this thing? Like, not to be like, that's not like conspiracy-ish. It's just that like there's probably some other revenue stream in there. So like if it's like, so if you go and get like a Google Home speaker and it's $20, it's It's like, and you look in it and you're like, there's probably $20 of parts in here, even at
exactly.
high volume. It's like they're making money some other way, right? And it's just like,
that's it.
Yeah, I mean, if you're not paying for it, you're the product kind of thing. And I think that's
the product. Yes, exactly.
That is definitely the. I worry more about the consumer sentiment around it and like the expectations, of course. Like people being like, oh, well, it has to be $20. Why isn't it $20? And it's like, the way that I deal with that is I just kind of opt out. I'm like, well, I'm gonna pay for the prosumer version of it, or I'm going to if I'm designing stuff, I don't design stuff for the consumer market because there's no way I can get the volume or the the timeline for that sort of stuff. So it's just okay, fine. I'm not playing that game. That's and hardware is more expensive.
Yep.
And hard to get. If that's what I was trying to say, is hard to get too.
Right.
Parts are hard to get these days, Dave. I don't know if you know that.
So like lead times and stuff have been killer apparently.
Yeah.
Geez, right. It reminds me of the 90s, and the days of Maxim, and like 40 weeks lead time. It's like
that's right.
I think that sort of stuff's coming back.
I seen there was so I was looking at the CM4, the one that we talked about here earlier, the Ethernet RF thingy. That's the compute module, right? I was looking at that for a project I want to do,
right?
And some of the modules you can't get till May. It's just like that's 6-month lead time type of thing, and some you can, right? It is swappable, whatever, but it's like, they're just kind of way out there. It's just crazy because I think
it was only last year that we were joking about on the show, I'm sure, about how that was such a thing of the past, how these long lead times were a thing of the past.
Yeah.
Oh yeah, I remember that when I was a boy, and like, no, it's back.
Yeah.
Wow.
Yep.
So, yep.
Yeah.
Whether or not is that going to be a temporary, because like half the world's shut down with COVID, Australia's doing fine. We should start up manufacturing again,
You should. Yeah, try it, man. Yeah. See how it goes.
Yep. Yep.
Have you looked at the compute module, the Raspberry Pi compute module?
I've had a quick squeeze at it. I'm thinking about designing a custom board for it, so we'll see what happens.
I've started to do that for a project I'm working on, and
it's still not the best bang per buck. Like it's like if you want, there's others out there that have better processing bang per buck than the Raspberry Pi.
Oh, sure. But can you buy them? Yeah. Well, like what's an example of that?
Oh, like the like the instead of the Raspberry Pi, you get the Orange Pi and stuff like that. Right. I see. Okay. So they're not quite compute modules, but you can, there's no reason you get more bang per buck in like an Orange Pi than a Raspberry Pi, for example.
I see. Yeah.
Yeah.
Yeah, but this is the actual like compute, like the module.
Yes, this is a compute module.
It's actually integrated to a product, and you have to run.
It doesn't just use a pin header anymore. It uses a high speed, a Samtec high speed connector.
Yeah, like a mezzanine connector. That's right.
Yeah, mezzanine connector. So that now, which means you can't stack them vertically now, which is kind of annoying. You can't like.
Well, you could though. I mean, you could put them side by side. You could.
Yeah, but you'd have to design another daughter. You'd have to have yet another mezzanine board to plug your compute module in that then plugs into the motherboard.
Why would you want to stack them vertically? I don't get that.
Density for a cluster.
Oh, I don't do that. No.
Yeah, exactly.
Yeah, I think that's probably a good point though. Like the form factor has switched away from a
vertical to a horizontal.
Well, yeah. So in like a SODIMM, so you could have plugged them into like row. But yeah, this would have to be side by side or some other way. But I think this is interesting new way to do it.
Yep.
I've been looking at it, and so there's a friend sent me the high speed layout guidelines for signal conditioners and USB hubs. It's like a TI app note.
Yep.
Highly recommended. It's nice, friendly diagrams, good background info, all about high speed reference planes, stuff like that. So if you're getting into it, I do recommend that. Looking through that, it's a really good resource for controlled impedance differential pairs, things like that. And
cool bananas.
Caps in the right place, all the stuff that Dave already knows about that.
Yep.
Yeah. You should make a board though. It'd be interesting to hear your take on it. You could use version 6 of KiCad. It's I
was going to say, because they actually provide. That's the other thing. Do actually provide KiCad files, don't they?
That's right. Yeah, the IO board is in version 6. So.
They provide a template. They provide it.
No, it's the actual board that they make. They make the I/O board. So it's basically like, yeah. So the board itself, the module itself is in.
Oh, so the entire board is KiCad.
Well, the entire I/O board. So like the breakout of all the signals.
Oh, the breakout of the
design.
signal. Oh, okay, right. The reference. Okay, not the actual Raspberry Pi itself.
Right, exactly.
Right, because that's all closed source. The Raspberry Pi is not an open source design.
That's right.
They don't release schematics. They don't famously release,
Yeah, so you can access to the headers and things like that. But if you're not going to be able to buy, you couldn't buy the chip. You couldn't buy the BCM chip anyways, the Broadcom chip.
Right. Okay. Yeah. So exactly.
But this is kind of like the next best thing, and the I/O board is open source, and you can get the files and stuff. So yeah, it's a nice change. It's the only downside is if you are in version 6, you can't go back to 5. So just keep that in mind.
Oh, really? Okay.
Yeah, it's a one-way trip. Nice. So that's why I have it on a VM, because I don't want to.
Okay.
I'm not moving my other designs there yet, so I don't do that until V6 is solid, which is probably early 2021. So
yep,
we're getting there. We're getting there.
Cool.
But yeah, you should do it. It's cool. I mean, it's a good opportunity. This is a great app note. You could go over this app note in your videos and stuff too. It's like
awesome,
good stuff.
Link
and like when Jay,
link it in to the show notes.
I will. When Jay was on the show too, he talks about a lot of this stuff. He was talking about his. So Jay Carlson was on the show. The student he was working with, was doing layouts of DDR memory and stuff like that. And it was just like, it is this commonplace thing, but there's a lot of question marks around it. I've always had a lot of question marks around it too. And it's like, it's just becoming more commonplace. And so like even doing controlled impedance traces out to like an HDMI, connector or something like that, you still have to know some of this stuff, but it's just becoming more accessible. And that's probably easier than DDR3. And like Jay was saying, the DDR3 even is easier than it used to be. So I think that's all a positive direction. And so like showing that kind of stuff is easier and figuring it out. So yeah.
Cool.
Yeah.
All right. Our amp hour's up.
Oh, it is. What do you know?
Yes. Oh, there you go. Flew by. So, yep. Just remember this. I'll leave you with a final thought. In the future, you will own nothing and you will be happy.
Do I agree with that? I don't agree with that. I definitely won't be happy.
So you're against the Great Reset. All right. I had to get it in there. It's fun.
Yeah. Okay.
Yep. All right. I will go and buy my own pick and place machine before I can't own anything anymore.
Okay. Yeah, that'll make for some great videos. So you should do it, man. Get yourself a Charm High.
In my new Charm High, in my dodgy Charm High, in my new 50 square meter lab. Yeah.
Hey man, you know what you could do? You could loft it. You could like put it like on a winch cable.
A hoist. Yeah, the hoist.
Hoist, right? Exactly. So so past guest Todd Bailey, he did this with his bed in his Brooklyn loft. He actually had a winch that like lowered the bed up and down. You could basically just build this thing when it's not in use. Goes up to the ceiling.
Yep.
And then when you need it, it comes down.
Yep.
I mean, you can do this with a train set too. You could make it. You could make a whole second level in your lab, Dave.
Yep.
You could really.
I could do it in the bunker. I got tall ceilings in the bunker. I could have a whole mezzanine. I could build a mezzanine level in there.
Build a second level. There you go.
Yeah.
Right. You could collect all the crap that you already collect.
Yep.
All right. Well, see ya.
Catch you next time.
If you dig into the programming manual of today's episode, you'd see a register set that is maxed out by default, and that'd be the generosity of our patrons. Join the club at patreon.com/theamphour and join our Discord so Chris has someone to talk to about firmware. A special thanks today to our corporate sponsor, Binho.